Good days and gentlemen. How's the day? How's everything? Today we shall be dealing with the types of limits. Now, in last class we discussed the introduction to limits, that's what limits is, and I'll just paraphrase about this. And if you've not watched the video, you can go back to check it. Click the link below in the description below. And now limit. Now I said limit is actually is a condition whereby a quantity approaches another quantity without getting to that quantity, in which I discussed using a particular curve to explain. This is point Q and this is point P. They are together like this. Let me make this point P then. So I said, what if Q is to approach P? To Q0, to Q1, to Q2. What happens? It approaches P. But when I now say, okay, let Q tends towards what? P. It will never be equals to P. That is, Q tending towards P is very different from Q equals to P. And I described this phenomenon using a particular example of if y is equal to x squared. If y is equal to x squared, and say limit x to tends to be 2. So I say y is equal to 2 squared, which is equal to 4. Now if I were to make use of limits, I wouldn't do it directly like this. I'll be using figures close, and I told you we have two limits, which are the right limit and the left limit approaching point 2. So actually here it will get to 3, 4. Here 1, 0, minus 1. So the point is, as coming to 2, what happens is from 4 it will reduce to 3, from 3 it will not come to 2 because it is only tending towards 2. So actually it will reduce to maybe 2.1. So from 2.1 you still have 2.01, you still have 2.001, we still have 2.000001. The point is that it is not equals to 2.0. It is always carrying a 1 behind it. That's the closest it could be. So it is only approaching. The closer it gets, but still not touching. So same thing from here. I can have 1.9, 1.99, I can have 1.99999. All the same, or none of them are getting to 2, but they are closer to 2. So I can now say, when I say my x tends to be 2, I can actually say x is approximately 2, because when we approximate all of this, they will still give us what? 2. When we approximate all of this, they will still give us 2. I understand, and I use pi as an example. I say pi is equal to 3.142, whereby this is not the actual value of pi, it is only the approximated value of pi. So in that case, this is only approaching pi, but it is not pi. So I can say this is when pi tends to be this 3.142. I hope it is clear. So that's just it. And I now wonder, why will a number approaches a particular number or approaches a particular quantity without getting to it? What does it mean? What does it mean? Now, if I'm to ask this question, between 1 and 2, how many numbers are there? How many numbers are between 1 and, let me say, 10? How many numbers are, let me say, and 3? How many numbers are there? I know you will be saying we only have one number in between, which is 2, and this is just a wrong answer, because between 1 to 3 we have millions of numbers. The numbers we have in between are infinite, and no man can even count it. Because someone gets you may think 1, 2, 3 and 2 and that's all. No. Where did you keep 1.1? Where did you keep 1.2, 1.2, 1.4, 1.5? Where did you put 1.01, 1.11, 1.123, 1.121, I've not left 1. Let alone going to 2 before getting to 3. So we have many numbers between these figures, and that's the reason it is possible for a particular figure to approach and not touch it. Now there are now two things. Now, if a number is approaching and not touching, it means it is approaching a particular number. Now there is one number that is the largest number. There is another number that is the smallest number, and still it doesn't exist. We have a very big number and still does not exist, in the sense that, who can tell me the largest number we have? None. Because if you tell me it's 1,000, we still have 10,000. If you tell me it's 10,000, we still have 100,000. If you tell me it's 100,000, we still have 1 million. it goes on like that. So we have the particular number that is the largest number, and still it does not exist. Why it does not exist? Because of nobody knows it. Just like Kirsten said, he said a particle only exists if it is being observed. That is, no particle if it is not observed. So same thing happens. So the largest number is not observed, therefore it does not exist. But we know it is. We know there is. So it's same as the smallest number, the negative integer. Which one is the smallest among all? We can't tell it is this. If you tell me it's 0, we have minus 0. We have minus 100 rather. I hope that is clear. So that's that. So we can say the number that can be approached and yet not still touched is what we refer to as the infinity. So we now just gave it a name. Let's call it an infinity. It is so small or so big that you cannot even imagine it. Then your thought, your imagination just cut off. It's called infinite, and it is represented with this. I hope this is clear. So that's just that in summary. And okay, now let's move to today's one, which are the types of limits we have. The types of limits. Now we have three basic types of limit, which are the first one is the positive limit, second one is the negative limit, and the third one is the infinity limit. These are the three types of limits. So let's pick them one after the other. Let's deal with positive limit first. Now, positive limit. This is actually a limit that can be used. It is only a limit. It is a limit. It is a kind of limit whereby the limiting value is a positive integer. The limiting value is a what? Positive integer. That is, if I tell you, okay, like the previous example, y equals to x squared. Definitely, the limiting value, okay, limit x should be what? 2. This is a positive limit because the limiting integer is what? Is positive. It's a positive integer. So if I tell you, okay, from this same question, limit x to be 5 is still positive limit. So that was the example of a positive limit, whereby the limiting value is a positive integer. So, and these are just the examples. Then the second one, okay, then just leave it there. So example, e.g. I have, when I have x plus 2, y equals to x plus 2, whereby I limit x to be equal to 1. So that whereby it is a positive integer, that's just it in summary. The negative limit. The negative limit is actually whereby the limiting value is a negative integer. So for instance, if I give you y equals to x squared plus 3x minus 5, and I say limit x to be equal to minus 3. Now I have minus 3x. Now there is now one thing about negative integer. Now it is denoted like this. You know, here it is denoted as x tends to be maybe 2, some maybe x tends to be 9, etc. But in this case, it is like this. You know, okay, for instance, like I have negative 3 now, negative 3. This is the way it is being written. So negative 5x. It is like this. Do you now know why? Because on our axis, I have my 0 here. My positive integers are on the right, and my negative integers are on the left, isn't it? So actually, if this is my x, so if I'm limiting to a positive value, it is on this side. To negative value, it is on this side. I hope that's clear. So this is for the positive limit and this is for the negative limit. So it is denoted like this. This is the way it is being written. It is not like this. X tends to be -5. No, this is the wrong approach. It is wrong like this. So that's the way it is being written. Just like the way I've explained here. So that's that about that. So the third type of limit, which is the infinity. Okay. Okay, this is where we have the limiting value to be infinite. That's where the limiting value is infinity. So infinity can be positive or negative, either ways. So I can say x tends to be infinity or minus infinity, then x tends to negative infinity. You see I still apply this. So that's where it is. So this is when I have, for instance, let me say my x cube, plus 5 all over s plus 2 equals to what? Let's say limit s to be what? Infinity. Or the same question, y equals to, okay, let me just say s cube minus 2. Then I say limit s, okay, limit s to be negative infinity. So that's just the way it is. So that's just about the types of limit. That's about that. So now let's move on to the methods of finding limit. Methods of finding limit. Now, methods of finding limits. Now, we have 3 basic methods, but as for the third method, I won't be treating it now. And why? The reason I'll be treating it now is because we'll be making use of a branch of calculus, a method of differentiation there, that which is referred to as the differential notation that I named the direct rule. So with that's when we'll now come back to the third method. So now the first method is direct substitution method. Direct substitution method. And the second one is factorization method. And the third one is L'Hospital's method. Now this third one is the one we won't be treating now, because we'll be making use of differentiation there, because we'll have to differentiate. There's a way we do it, sure. So but I will have to treat a particular branch. Now I give you branches of emphasis. The method of differentiating, which I started with limit, then I moved to direct rule. After that, I moved to first principle. So now, for me to treat the third, this L'Hospital method, I will have to treat this direct rule. Because if I should take it now, it will just be like, what was it doing? Because in case if you don't have the primary knowledge of direct rule before, you may not be able to understand this method yet. So that's why I won't be taking it now. So let's start with the direct substitution method. Now, the direct substitution method. The direct substitution method. Now, for instance, okay, example 1. Let me give the definition first. Now, this method is used when the given function is not a fraction. It is only applied to a given function which is linear. It can be linear provided it does not involve any denominator and numerator. That's just when. So it can only be applied for questions like x squared plus 3x minus 4. Questions like, okay, questions like x minus 1. Questions like, let me bring this back. Questions like x minus 1. Questions like, if y equals to this, if y equals to this. Questions like, y equals to sine x. They are all linear. It doesn't involve any denominator. So that's when this method can be used for the direct substitution method. This can be used for fractions too, but sometimes it doesn't work for all fractions. So that's just the way this is. And okay, let me now assume limit x to be 2. Yeah, let me limit x to be minus 2 here, or minus 3 instead. Yes, then here let me limit x to be, okay, 30. Yeah, now I have 3 questions. I'm now to solve them differently. Let me divide them, give them their columns. Okay, so for this, it's only explaining that since I'm limiting x to tends to approach 2, it simply means anywhere I see x, I can put 2, because it's only saying x is approximately equal to what? Equal to 2. So I'll be doing that, saying y equals to, anywhere I see x, I put 2 squared plus 3 2 minus 4. So y equals to 2 squared is equal to 4, 3 times 2 equals to 6, minus 1. Let's remove this. So y equals to 6. As simple as that. That's a direct substitution. That is, we substitute for the value of x directly, nothing more. So for this place, it can, already this is equal to, my x tends to be minus 3, right? So I have minus 3 minus 1. So y equals to minus 3 minus 1. Y equals to what? Minus 4. That's all. For this, y equals to sine, s tends to be 30 here, so equals to 30. So y equals sine 30 is equals to what? 0.5, and that's all. So that's that about the direct substitution method. When it is being applied directly, and at the same time, it always works. Let me put it that way. It always works for every linear function. If the given function is not a fraction, it will always work. But if it's a fraction, sometimes work and sometimes it doesn't work. So that's the reason it is basically for this. So let's move to the second method, which is referred to as a factorization method. And now don't forget to subscribe this channel, just the free command, like, share, and also comment video. So the part 2, I have my factorization method. Now, this method is used in if and only the given function is a fraction. Yes, if it is a fraction, and that's if the denominator and numerator of that given fraction are factorizable together. For instance, let me say we are given x squared plus 3x minus 4 over x minus 1. Now, if y equals to this, now looking at this question, now if I'm to apply, let me now assume my limit x to be 1. Now I want to tell you the reason direct substitution will not work here. Now direct substitution will not work here because, let us even try it. Now, using method 1. That's direct substitution method. So then my y will be equal to 1 squared plus 3 into brackets 1 minus 4 all over 1 minus 1, right? So y is equal to 1 plus 3 minus 4 all over 0. So here I have 4 minus 4 over 0 equals to 0 over 0. It's giving me infinity, and it is a must we get a particular value for the what? For the limit. So us getting infinity simply means, and infinity also referred to as indeterminate. For me, I call it meaningless. Yes, it is meaningless to us. What's the figure? It exists, but we don't need it. So it's also meaningless. So we got to get a particular value as our limiting value. You get it? So that is the reason method 1 may not work for all fractions. And for some fractions it would work. Yes. So for now, if I should limit x value to be 2, direct substitution will work for it. Okay, let me just do it to make it clear. Okay, let me say my y is equal to s squared, the same question, minus 4 all over s minus 1. So I limit x to be 2. So my y will be equal to 2 squared minus 3 into bracket 2 minus 4 all over 2 minus 1. I'll be having 2 squared is 4. 3 times 2 is 6 minus 4, right? All over 1. So is it 4? This remove this, divided by 1. My final answer is minus 6. Direct substitution worked for it if the limiting value is not 1, but it didn't work for it. So that's why I said it wouldn't work for all fractions. It worked for some and it will not work for some. So that's the reason factorization method is better when it comes to this. And factorization method also doesn't work for everything, because the denominator and numerator must be factorizable. That's one condition for factorization method. If it is not factorizable, then it wouldn't work also. We'll have to employ this third level. So now let me explain the factorization method. Now, using factorization method, it simply means, now looking at the top, I have a quadratic function there. The denominator, I have a linear function there. Definitely, if I can factorize this one into two different linear fractions, one of them can possibly be this, where I can cut each other. So to be left with one of the linear functions, then I'll now apply the direct substitution method. So it's more or less like reducing or simplifying this to a linear function in order to apply the first one, which is the direct substitution method. So that's just what factorization method is all about. So if you don't know, you can also check our videos under quadratic equation using factorization method. It's there, so you can check it on how to factorize the quadratic function. So now let's just factorize this. I have s squared plus 3x minus 4, right, equals to 0. I want to factorize this now. Let me use the formula method so that it will be fast. If I choose factorization method, it will look confusing or something. Okay, let me use factorization method. Okay, here I have minus 4x squared. So what are the two numbers I can add up, and also I can have minus 4x and what, and x. So minus 4x plus 1x plus x minus 4x will give me plus 3. If I multiply, then it will still give me this, right? So I can also have x, okay, one of them to be minus, then here I have 4x, isn't it? So sorry, minus, I can have it this way too. I can have it 2x minus 2x. I can have what else? Okay, let's just stop here. So now, which of them, if I'm to add them now, to give me, this one will give me plus this minus this, it will give me 0. The b is not 0, so this is out of the game. Plus this minus this will give me minus 3, but we have plus 3x there, it is out of the game. This plus this will give me plus 3, so this is what we'll be applying. You can go back to the video, the link will be in the description below, so just go there to check how this is possible. So now here I have minus x, right? So plus 4x minus 4 equals to 0. So I'll group them into two groups. So factorizing this, I have x into brackets x minus 1, then plus 4 into brackets x minus 1 equals to 0. So I have s plus 4, s minus 1 equals to 0. I factorized it like this already. So I'll just substitute it now. So I'll now say my y is then equal to s plus 4, right? S minus 1 all over s minus 1. So this can remove this. So now my y is now equal to s plus 1. You see I've now reduced this. So I'll now limit my s to be 1 now. So my y will then be equal to 1 plus 4. Y equals to 5. I've gotten the value of my y using what? Factorization method. So that's the way it is. And as for the factorization, you can check our video. I will click the link in the description below. So that's that about factorization method. Now for the El Hospital rule, for the head hospital method, I would have loved to do it now, but I would prefer to treat direct root first, which is also referred to as the differential notation, before coming back to this. So probably don't forget to subscribe to this channel, just the Fiken Math. So we'll always be at your service. Just any challenge you have, just drop in the comment below, so we'll be able to attend to it, and also share with your friends, classmates, everywhere. So thank you very much. Thanks for watching. Meet you in our next class.